In this video, I will show you how to build a simple and automated boom barrier. So to build this project, we will need two IR sensors. Okay. A servo motor. I've already connected a straw to the servo motor. Okay. Some jumper wires. An LED, the Arduino board, and a breadboard. So now let's build a circuit. First we'll use only one IR sensor to build the circuit. So there are three pins of a servo motor. One is the first one, the yellow one, is signal, the red one is positive, and the brown wire is ground. Okay, so before I connect the servo motor, I'll take the Arduino board and connect the positive leg of the LED to pin 13, digital pin 13, and the negative to ground. Okay, now I'll get 5 volt from the Arduino board to the breadboard, to the positive rail of the breadboard, and ground. I'll take black as ground. We're gonna ground negative rail of the breadboard. Okay. Now I'll connect the servo motor. So now I'll take red one for positive, and this one for red one for positive, this one for signal, and this one for ground. Okay. Now I'll connect the signal pin of the servo motor to digital pin number 7 on the Arduino board, and positive to the positive rail. I took the wrong. Okay, so this. Okay, and I'll connect this one to the positive rail of the breadboard, and ground to the negative rail of the breadboard. Okay. So now we'll connect the IR sensor. So we are going to use the analog pin, this one, for analog pin, okay, which will connect to analog pin number 0. So I'll use the yellow wire to connect it to a 0. Okay, I'll take the orange one for positive, so positive is here, connected to the positive rail of the breadboard, and the other one to ground. negative rail of the breadboard. Okay. Look at this. Okay. Now we are going to make a model. So first we will start by including the servo.h header file. Next we are going to declare some statics integer, static integer. So in static we'll declare LED pin. So we have connected the LED to pin digital pin 13, so we'll give 13. Okay. Next we'll create an object of our servo motor, so I'll give servo and I'll name it as servo. Okay. Next we're going to declare some integer variables, so we'll give servo angle, which we'll use to control the angle of the servo. We'll assign it with 0. Next we are going to give the other variable as analog IR pin in, which we have connected to A0, which is analog 0. And next we'll give analog pin in and we'll assign it with 0. Okay. Now in the var setup we'll start by serial.begin, give the value, this is 9600. Okay. Next we are going to set the pin mode of LED pin and analog IR pin in. So I'll copy this one, paste it here and set it to input. And the next one to pin mode as LED pin, and I'll give it as output. Okay. Now we'll set the LED pin to low, so we'll use digital write function and give LED pin low. Okay. Now we'll write the angle to the servo, so we'll give servo.write servo angle. 0 means its normal position closed. Next we'll give the pin number where we have connected the signal pin of the servo motor. So we have connected to digital pin 9, so we'll give servo dot attach 9, digital pin 9. Okay, so this is the setup. We don't need this comment, so I'll delete it, and this one too. Okay. Now in the while loop we are going to assign analog pin in with analog read. So we'll read the analog IR pin in. Okay. Next, we'll print the value, the distance. So give serial.print and give analog pin in. Oh. And then serial.println will give the analog pin in. Okay. Next, we'll give an if condition. So we'll give check if analog pin in is greater than 700. Okay, so it will make the digit LED pin high. Give LED pin high, so means that the LED will start glowing, and then we'll call an open door function which will create in some time, and then we'll give a delay of 3000 milliseconds, which is 3 seconds. Okay. Now we'll give else if it's not greater than 700. Then we'll call closed door function. Okay, and we'll set LED pin to low. So we'll give LED pin low. Okay. Now let's create the functions. So first we'll create open door. Okay. So in open door, we are going to write the servo angle. So we'll give servo dot write. We will give 90. Okay, so this is open position, and in closed door we'll set it back to normal. Okay. We'll also give delay of 50 milliseconds. Okay. Now I'll verify my code. So it's done verifying, and now I'll upload the code. Maybe the light is I open the serial monitor. So it's greater than it. It's glowing. Oh. just keep it like this. Okay, maybe the light is affecting it. Now I'll get it close. Okay. Here and now. So now it's working fine. But now I say that if when I'm getting my vehicle close to the IR sensor, it's opening. But when the vehicle is trying to get out, then the rod is hitting it. So to fix this issue, we'll go back to the code. Let's close the serial monitor. We'll give for loop. So we'll give for we'll give semicolon, then we'll give servo angle. We'll use the servo angle less than 90 degrees. Then we'll give servo angle plus plus, and then it will write servo angle like that, and then over here we'll give servo angle. I'll copy this for loop and paste it here. Oops. I'll delete that, paste it here, and then I'll give 0 here and greater than 0. Then we'll minus and give delay 50. Okay, so now I'll upload the code. Okay, now I'm uploading. I'll increase the delay to 800, maybe. No, to 800 will be fine. Let us check it first. Done uploading. Oh. I'll make this to 3000 and this one to 3000. Upload it. Okay. Still it's not working. If I change this back to 50, so I'll change the for loop to while loop. Maybe there's a problem, so I'll give servo angle less than 90, and here I'll give servo angle plus plus. I'll copy the same line, paste it here, and give greater than 0, and I'll give servo angle minus minus. Okay, so now I'll upload the code. Okay. So okay, now I see that it's opening slowly. And now it's closing slowly. Now I'm gonna come here. And now you see that it's closing slowly. Okay. You see, like right there, it's closing, and it has to come like this. So to fix this issue, we'll connect another IR sensor to the project. So I have another IR here. So I've connected this one to analog and the others to positive and negative. So keep the IR sensor here. Wire like that. Now the blue one is negative. Just check it again. Okay, it's negative. So I'll connect it to the negative rail of the breadboard. The other one is positive, so I'll connect it to the positive rail of the breadboard. And the yellow one, I'll connect it to a analog pin 1. Adjust it. Okay. Yeah. So first we'll declare some integer variables. So I'll copy this variable, paste it and set it to a1, and I'll give this out because the card will come out. Now we'll set the pin mode of the out, so it's input, and we have to also copy this one like that, and this one will be out. Okay, now we'll go down. I'll copy this line, paste it, give out, and here out, and here I'll give I'll copy this line, these lines, paste it, and give out, and here I'll give out. Now we'll write an else if, and else if will give the condition as we'll write analog pin out greater than 700, the brackets, and digital write will set write we'll set LED pin to high. Okay, and we'll call the open door function, and we'll give a delay of 3000 milliseconds. Okay, now we will upload the code. We'll check it. So I'll upload it. Connect the positive. Closing. Now close here, and you see it's opening. Now it's closing. Just switch off the light for a moment. Okay. Get it near. So that means that our model is working fine. Thank you for watching this video, and I hope you found this video interesting.